Hey guys, it's Elsek back again with another antivirus bypass video. We're gonna talk about something called threadless injection, and it's an injection techniques that makes your payload to be super evasive. Now, it was originally brought to the world by Ethical Chaos, and the full link to the conference can be found on the top right corner. I was so amazed by the techniques that I decided to create my own implementation in C so I can learn the language better and also contribute to the open source world. Now let's get into details on how this works, what does it do, and why it's so evasive. In order to understand threadless injection, we need to address the Windows architecture and the Windows APIs. Windows APIs are wrapped methods which are called when you create some kind of actions. For instance, if you create a file with Notepad, create file W function will get involved. The problem is that a lot of the times Windows APIs are abused for malicious behaviors. For instance, shellcode runners, as shown in my previous video, uses Windows APIs to allocate memory, write our payload to that allocated memory, and then execute it with a new thread. This behavior is extremely suspicious for AVs and EDRs, and what threadless injection do, it dechains the first two steps from the third one, which means that using threadless injection, we can allocate the memory, write our payload to the memory, but let the Windows do the heavy lifting for us and execute the payload.
In a nutshell, threadless injection works by hooking a legitimate Windows function so that when it's executed, it's gonna actually execute our payload and then resume its normal working process. Okay, but how do we know what function to hook? Thankfully, we have tools for that, and one such tool is called API Monitor. This tool allows us to monitor a process in real time and see what the API call it's doing, including its parameters as explained in the screenshot. I have already downloaded API Monitor, and let's demonstrate how it works. When downloaded, make sure to click all these filters so you can get the most coverage out of the process. Now I need to start a new Notepad process, and keep in mind that I'm just testing with Notepad. In your environment you will choose a different process, and then just click here, which is going to actually attach to the process and start to monitor it. Now we don't see any API calls because the Notepad is idle, but if I go and poke it a little bit like that, if I go back to process monitor, we can see a lot of API calls in runtime. Now, in your environment, you want to choose a function that's called on time interval, and that's because you don't want to rely on user interaction. For instance, in this demo you're gonna see just now, we have hooking, create event W function, which is invoked as soon as someone saves a file with Notepad. To avoid this behavior, choose a function which is called on time interval so you don't depend on users whatsoever. I have loaded my POC in Visual Studio, and now let's analyze how it works. The key components are the following. We have the shellcode loader, which is designed to be a custom shellcode, which is going to redirect the execution flow. Then we have our malicious shellcode, which is designed to give us access, and then we have the main method, which requires 4 system arguments. The first one is of course the function, the program itself. Then we have the module we wanna see the function from, then we need the function we want to hook at, and then the PID of the remote process. Here we parse the arguments, and here we pretty much ensure that the module is correctly loaded. After that we open the process, and then we jump into a function called find memory hole. This function gets the exported function address, which is the exported function we specify in the system arguments, gets the address to it, and then it calculates a slight offset after it. This offset is then used to store our shellcode loader, and then we need to allocate the memory to that offset address with the virtual calc.exe API. After that function is completed, we jump into another function which is called generate hook. The generate hook function restores the original native flow, so it modifies the shellcode loader variable to contain a call instruction, and that call instruction to be equal to the original bytes that are from the original function. So when that function calls, it's gonna call the shellcode loader, which is now modified to call the original function instructions when it finishes executing. After that, we have to craft one additional piece of custom shellcode, which is designed to perform the initial hook. That initial hook is gonna get allocated and written to the exported function address, and what's gonna happen is that after we write this shellcode there, it's going to call shellcode loader, which is going to call our malicious payload, and then the shellcode loader is going to finish the execution of the native function. Then we need to craft our final payload, and then we need to tweak the memory protection settings, write the payload to the memory hole address, tweak the memory settings again, and then just wait the Windows do the heavy lifting for us. To demonstrate how it works, I have prepared the calculator shellcode. Now, this is just for demonstration purposes, and in the original POC you have the option of specifying the shellcode from file. This option is missing here because mainly for 2 reasons. First reason is I want to make things as simple as possible, and the second one, I am learning along the way as well, and it's easier for me just to specify calc.exe and see if it works. Now, this is as I mentioned, calc.exe, so I'm going to compile that as release, and x64 I'm going to do ls threadless inject -c.exe, and here we have the syntax. Now let's specify kernel base .dll and create event w function, because this is what we want to hook, and pretty much create event w stays and lives inside kernel base.dll, and then we need to specify the PID of the notepad process. For this to happen, I'm going to actually open a notepad process here, and I'm going to open also process hacker 2 and search for notepad. Now after I did that, we can observe that the notepad process has the PID of 13160, so I need to provide that here, 13160, and run the application. Based on the output, we can observe that the function is successfully hooked. Now if I go back to the notepad application and try to save any dummy file, we can observe that the calculator.exe is right off the bat being spawned, which means that our shellcode is successfully executed. Now you may ask, alright, but how to weaponize that? So let me show you how to weaponize it with the msfvenom and a custom shellcode generated from it. Now for that to happen, we need to first replace this variable here, because this is, as mentioned before, our malicious shellcode. Keep in mind that if you replace this variable, it's not gonna work, because this is pretty much our hook. Now let me get back to my current machine and generate a simple shellcode for you guys. This Windows x64 and stageless reverse TCP, the ETH0 will be the host and the port is 9443. I want the format to be in C because I just want to copy and paste the shellcode just for demonstrational purposes. So I can copy this big piece of code, then go back, replace it to here and rename it to be shellcode. Now I can recompile that, and then I need to spawn another notepad process. I can do notepad, take note of the PID, which is 16824, and then run the exact same command, which is 16824. Now let me get back to the same pane there, and then I can click run. Now before that, I need to set up my listener, so I can do nc mvop 9443. Then I can just simply run exactly the same command, go back to the notepad application and try to save something. When I do it, we can see that the notepad application works, but if I go back, we can get a shell. Thank you so much for watching, guys, and I have to especially thank Palangus Jose and Alan, sorry if I pronounced your name wrongly, for your Patreon support. You have no idea how much that means to me, how much I appreciate it, and how much it makes me feel motivated to perform and do more content like this one. I have to apologize that in the past month I was not that active on YouTube, but a lot of stuff were going on for me, and it was so hard for me to manage all this stuff and record the video. But expect more for the future. Happy New Year, and see you in the new one.